Question number 3. A worker drags a crate of mass 20 kilograms. So this is 20 kilogram with a force F. The crate then moves at a constant velocity. So constant velocity means acceleration is 0, 4.8 meters saja. And then the coefficient of kinetic friction, remember, coefficient of kinetic friction is not the friction force, it is mu. One gitu, mu. Yeah, it's too big. Macam mana suatu mu? Oh my god, how did I? Mu. Gitu kali saya buat selalu. Okay. The coefficient of kinetic friction is 0.4. So sekarang ni kalau kamu bingung coefficient tu friction force atau tidak, kamu tengok ada unit atau tidak saja. So now 0.4 does not have any unit. So maksudnya dia adalah coefficient of kinetic friction. And then we have to calculate the work done on the crate by the normal force, work done on the crate by the force F, and the total work done on the crate. So firstly, what we need to do, remember we always need to draw a free body diagram. Okay, so bila kita nampak something, bukan nampak. So, sila pula, ano ba sa balik? Okay, so sekarang ni kita akan do it like this. Actually, I'm just gonna directly draw it here lah. Okay. Okay, so this is our X and Y axis. Now remember, kita punya weight force will always be pointing downwards. Sekarang ni apa yang Miss jumpa time Miss mark kamu punya work is you always most of you salah lukis apa tu weight force. Okay, contohnya sekarang ni kita punya box memanglah incline kan, tapi tiba-tiba dia kamu pergi buat weight pun macam ni. Sedangkan Miss ada cakap weight sentiasa pointing downwards. Ini tidak akan jadi mg. No, this is not mg. Yang mg tu di sini. Okay? Lepas nanti dalam class, I'll explain it to you again lah. Alright. So first kita akan ada normal and weight force. Sebab sekarang ni kita ada satu object which that is in contact with the floor. So dia akan ada contact surface ataupun normal contact surface. Dia ada contact surface, so dia ada normal force. And then we have the weight. Lepas tu kita ada force that is 37 degree from the horizontal. And then since dia ada bagi kita kinetic friction, maksudnya this is a rough floor lah. So remember, the kinetic friction mesti go against the motion. Alright? Jangan lupa angle. I think that is basically it. So we can then label the diagram lah. So make sure to always label your diagram sebab examiner tidak akan bagi markah if you do not label them lah. Buat apa kamu lukis arrow if you don't tell the examiner what it is. Okay, so that is the free body diagram. Lepas kita lukis free body diagram, kita barulah boleh solve the question. So we have the work done on the crate. We have to calculate the work done by the normal force. So sekarang ni normal force N as cos theta. So we have to consider the displacement. Sekarang ni displacement ni akan ke kanan lah. Okay, so bila kita letak ke kanan, because sekarang ni jangan kamu pergi lukis displacement tiba-tiba begini ya. No, the displacement is not that way. The displacement is going to the right. So this is your displacement. Okay, so kita label lah S di situ. Okay, tapi boleh jual lah Miss lukis sini supaya I can compare it. Can I just draw it here? Okay, so the displacement is pointing to the right. So apa angle between normal force and this displacement? It is 90 degree. So bila theta is equal to 90 degree, we can write down the value directly 0. Okay, so kamu tulis je lah 0 joule. Tapi kamu buat sampai substitution here lah. Right, and then the second one, we have to calculate the work done by the force F. So, work done by F. Sekarang ni, F, kita perlu darab dengan displacement and cos theta. Okay, so berapa angle the force and the displacement. Sekarang ni force ni ke sini. Sekarang ni kamu jangan ingat untuk apa resolve dia. Tak payah, kamu just perlu ingat yang kamu perlu kejap ah. Terbingung pula saya tengok ni solution. Yang kamu perlu cari theta tu based on force and displacement punya angle lah. So dari S ni pergi F, nilai theta dia 37 degree. So kita boleh letak F S berapa? S 0.8 meter cos 37 degree. Okay, tapi sekarang ni the problem is we do not have the value of F. So kita tidak the value of N pula F. Sekarang ni F is unknown. So macam mana kita perlu buat ni? Kita perlu apply chapter berapa suatu is it chapter 2? I think it's chapter 2 kan. Tapi kita perlu apply, oh my god, I don't remember. Oh, chapter 3 lah. Okay, we have to apply Newton's law of motion. Okay, so marilah kita apply. I feel like my videos is gonna be a bit long because lama sudah buat video. Okay, so kita start dengan force at the mana-mana pun boleh lah, x component boleh lah. So total force at x component, since the velocity is constant, our acceleration is gonna be equal to 0. Okay, so kalau macam ni kita akan buat F cos 37 degree minus Fk equal to 0. Okay, so kalau I expand this even more, because we do not have the value of Fk juga. Okay, so this is our first equation. Then we are gonna kita akan tengok y component as well. So in the y component there is no motion, so we can just directly equate it equal to 0. So that is n plus f sine 37 degree minus mg equal to 0. So if you have problem trying to solve this, you can watch my other videos lah. Okay, sebab saya sudah explain panjang-panjang dalam the other videos. Now we can then let n to be equal to mg minus f sine 37 degree. Okay, so we can then substitute 2 into 1. So that is f cos 37 degree minus mu k. Oh, gitu ba mu? Oh, nasib saya ingat sudah. Mu k, n is mg minus f sine 37 degree equal to 0. Okay, so from here, kamu just perlu substitute all the values that you have. Just make sure that you remember when you have a negative on the outside, it will be negative mg here, and then this will be positive f sine 37 degree. Okay, so from here you will then get the value of f to be equal to 75.5. Okay, 75.5 Newton. But make sure kamu tidak buat directly towards the solution, the final answer here. Make sure you also add on the substitution punya values lah. Because if you do not have the substitution, you might lose marks on substitution. Kalau kamu punya jawapan final answer salah, at least kamu ada marks for substitution. But then if you get the final answer wrong and you did not have any substitution punya solution, kamu akan dapat directly 0 lah. Okay, so from here you can then substitute the value of f into the one that we did just now. So substitute f into what do I write? I can just write wf lah. Okay, so that is gonna be equal to 75.5 0.8 cos 37 degree. So jawapan untuk yang itu, work done is equal to 48.2 joules. Alright. now we have to calculate the total work done on the crate pula. Okay, so what you need to remember here is the crate is at rest. Okay, so when the object is moving at a constant velocity, there is no change in velocity. So if we are going to apply work kinetic energy theorem, which is W equal to delta K, and if you remember, this is going to be equal to half m v minus u square, kan? Okay, so work done is only present when there is a change in velocity. So bila there's no change in velocity, there is no change in kinetic energy. So apa maksudnya? The total work done for this whole crate will be equal to 0 lah, sebab there's no change in velocity. Itu je yang kamu perlu ingat. Kenapa there's no change in velocity? Because sekarang ni the question already mentioned that the crate is moving at a constant velocity. Lepas tu, if you look at the y direction, the crate is not moving up and down, it is just moving to the right. Tapi dengan constant velocity. So acceleration pun equal to 0. Velocity pun tiada change. Maksudnya tiada change in kinetic energy. Okay, so that's why work done there equal to 0 lah. Alright, so that is the solution for question number 3.